So in this video, we're going to be looking at just the pink section for the review, and we'll be going over most, if not all, of these problems. I believe that there's a lot of questions on a couple of these different parts, and even though there wasn't a ton of questions on some of these earlier parts for number 1, for like A through D, I'm still just going to go over those real briefly. So it says, first off, write the polynomial in standard form. So for a lot of these problems, you want to make sure that you know how to do that. That means we're going to put this in descending order in regards to the exponents. So we'd have 5s to the 4th minus 2s plus 1. So most everybody got that one right. The only thing that I would point out about that is when we go to use your graphing calculator, you want to make sure if you have like the TI Inspire or some of these other calculators that have options of doing other letters other than X, you want to make sure that you always use X when we go to graph. But the degree for this would be 4 because that's the largest exponent. And we can see here that there's a total of 1, 2, 3 individual terms. And if you think about these, so some of you guys had a question on how do you know if it's a binomial or trinomial? It's based on the number of terms, not the number of variables, the number of terms. And so a term is separated, remember, by a plus or a minus sign. So there's 3 individual terms. So just like a tricycle has 3 wheels, this is a trinomial, would be your answer for letter C. And the leading coefficient would be just the coefficient. So we don't include a variable when we describe a leading coefficient. So in this case, the leading coefficient would be the number attached to the s to the 4th, so that's just the 5. Now the end behavior. Now this is where some of you guys had questions. Well, how do you describe the end behavior? Remember in the video, I talked about using arrows. And so we see that the leading coefficient is a positive 5. So we're going to have 2 sides of the graph, the left and the right side. The fact that it's a positive 5 means the right side is going to go up. And the fact that the degree is an even number, it's 4, means that the left side of the graph is going to go in the same, it's going to go in the same direction. So if it's an even exponent, the left side goes in the same direction as the right side. If it's an odd exponent, the left side goes in the opposite direction. And the way that we describe this, if you're confused about all these symbols, remember that this is referring to the right side of the graph, and this is referring to the left side of the graph. So as x approaches positive infinity, because if you think about a number line, on a number line from left to the right would be positive infinity, to the left that would represent going to negative infinity. So it's saying along the x-axis as you approach positive infinity, what's happening to the y values? Well, the y values on the right side of the graph are going up. And on the y-axis, positive infinity goes up, negative infinity goes down. Oops, looks like an 8. Negative infinity goes down. And so this approaches positive infinity. The end behavior for the left side, again, the left side is doing the same thing as the right. It's also going up, so it's also approaching positive infinity. Now to figure out whether or not it has a minimum or maximum or both, we need to look at the graph. And so we want to find the relative minimum, the relative maximum. So this one, there is a minimum. It's not even relative. It is the lowest point. There's no other lowest point than this. Now, at first it looks like it touches the x-axis, but it really doesn't. To be able to find out what that exact value is, we're going to do second and then trace. So second, so we can calculate. That's what the second trace does, is it gets to these calculations. We want to select minimum. And so remember, we set that cursor somewhere to the left of that minimum point, and then just hit enter on your keypad. And then we're going to arrow over anywhere to the right to that lowest point, and hit enter again, and then hit enter one more time, and there it puts the cursor at the lowest point. So the lowest point is where x is 0.464 and where y is 0.304. If we want to round that to the nearest thousandths place, we would round that to a 4. Or if we're going to round it to the nearest tenth place, it would just be 0.3. It doesn't say what to round to, so let's go ahead and round to the nearest thousandths place, so we can just be a little bit more accurate. And so going back to our review here, so the y value always represents the relative minimum or maximum. So when they talk about that, they're talking about the y value. So that would be 0.304. Now the turning point is referring to where it hits that turning point along the x-axis. So where does a graph change direction? Okay, so when it refers to a turning point, it's talking about where does it change direction. So it changes direction when x is 0.464. Let's look at the graph again. There we go. We read a graph from left to right. So as it's coming down, it hits that lowest point, and then it changes direction. So that would be a turning point. So it turns at x is 0.464. So that's how you get that answer. Now the next one is a little different, so I'm still going to do number 2 as well. So again, just real quickly, in standard form, this would be a negative 4s cubed. You don't want to forget about that negative in front. And then we'd have a positive 2s squared, because there's no negative in front of here, so it's a positive 2s squared, and then plus s. So the degree for this would be 3. The number of terms, again, we have a total of 1, 2, 3 terms. So this would be another trinomial. And then it's asked for the leading coefficient. The leading coefficient would be just the negative 4. And then let's look at the end behavior for this one. So again, we'd have 2 blanks, one for the left side, one for the right side. So we see that the leading term is negative. So that means the right side of the graph is going to go down. And the fact that this is an odd exponent means that the left side of the graph is going to go in the opposite direction. So remember, as x approaches infinity, that's referring to the right side of the graph. So on the right side of the graph is going to be going down. And so we're going to refer to this as, and again, some of you guys may be watching this part of the video and not the first part for question number 1. But along the x-axis, to the right is positive infinity, to the left is negative infinity. On the y-axis, going up is positive infinity, going down is negative infinity. So when it talks about it going as x approaches infinity, what's happening to the y values? So on the right side of the graph, what's happening to the y values? The y values are going down. So they're approaching negative infinity. So in part F, it says as x approaches negative infinity. So this is referring to the left side. So that's the left side of the graph. And the left side of the graph, we can see that the graph is going up. And when the y is going up, it means it's approaching positive infinity. Now let's look at the relative minimum or the relative maximum for this one. This one's actually unique because it has 2 points where it changes direction. So let's look at the graph so you can see what I mean here. First, let me go in here. Let's go to the graph. Okay, so we can see that it comes from left to right, it comes down, and then it hits this lowest point down, or it hits a low point, and then it comes up, and then it goes down, and it goes down infinitely. So this one, there is no actual minimum point. We only have what's called a relative minimum. But there's 2 points where it changes direction. So we're actually going to have both a minimum and a maximum. So when I go to do this, so I'm going to do second trace. So again, that gets me the calculation. I'm going to first find the minimum value. So I'm going to set that cursor anywhere to the left of that minimum value, hit enter. Move that to the right of that minimum value, hit enter again. So it gives us those 2 dashed lines, and so the minimum value is going to be between those. So I'm going to hit enter one more time. And there it gives me my minimum is negative 0.17 or 167, however you want to round that. And then the y value would be negative 0.093. So we could round that one, which we'll go back to our notes in just a minute here. Let's go ahead and find out what that maximum, what that point is right to the right of there. So I'm going to do the same thing. I'm going to do second trace. This time we're going to choose the maximum value. So I want to make sure you change that. So we're going to set it anywhere to the left of that maximum value, hit enter, and then move to the right of that maximum value, hit enter one more time. So now we can see that we're looking in between these 2 dashed lines. So hit enter, and there's your maximum, your relative maximum. So at 0.5 and 0.5. So the x and y's are both a half when we round those. So let's go back to our review. So again, I'm just going to, over here, just erase this. So we would have a minimum point was the coordinate negative 0.167 and negative 0.093. It had a maximum value of 0.5 and 0.5. And so as far as the relative minimum, the relative maximum, that's referring to the y values. So that is going to be both of these answers. So we would have a relative minimum at negative 0.093 as your minimum value, and then our maximum value would be 0.5. And then the turning points would be the x values for each of those. So the x values would be negative 0.167, because it turned at that point, and 0.5 would be your two turning points. So negative 0.167 and 0.5. All right, let's look at the back side of the pink section. It's looking at number 3. So it says, a sketch or graph using clues listed and identify the turning points and X-intercepts. All right, so for this first one, we're just going to go through each of these and identify some of the key points. So first off, it's negative on the intervals from negative infinity to negative 5 and from negative 1 and 3. Okay, so here's what that tells me. That tells me that, so it's negative from negative infinity to negative 5. So negative 5 would be right about there. So it's negative down there, so that means that negative 5 would be an x-intercept. And then it's also negative from negative 1 to 3. So negative 1 to 3, it's also negative. Okay, so it tells me two more x-intercepts are at negative 1 and 3. And it's positive on the intervals from negative 5 to negative 1. So from negative 5 to negative 1, it's positive. And from 3 to infinity, it's positive. Okay, so we can see that it's increasing on the interval from negative, so let's just stop there for a second. So that tells us we want to identify the turning points and the x-intercepts. So the x-intercepts, we can list now as negative 5, negative 1, and 3. So the turning points are going to be the points where it changes direction. So now my graph, again, we just estimated where these were. So now we're going to put in where the actual change of direction. So it increases. So from left to right, it's going to increase. It's going to keep going up and up and up until it gets to negative 3.5. So at negative 3.5, so actually I'll put a point there. At negative 3.5 is where it would change directions. Okay, so this graph would actually come up and then it would change direction at that point. And then it's going to change direction again. So it's increasing on that interval. It's also increasing from 1.25 to infinity. So 1.25 would be right about here. So that means from here to infinity, it's going up. So we'd have a turning point there at 1.25, and this one was at negative 3.5. So there's not going to be any turning points because the other points that we have in between there, because it's decreasing from negative 3.5 to 1.25, so just saying between those 2 points that we just identified at negative 3.5 and 1.25 is where it's decreasing, which makes sense. So the turning points would be at where x equals negative 3.5 and where x equals a positive 1.25. So that's how you do that one. All right, so for this one, if you notice, if you printed it out for one of them, it gave you the graph, and for this one, it didn't. Let me just do this here. So you could have graphed this on your graphing calculator and gotten the same graph here, or we could give you the graph. So you want to be familiar with both ways. And so the key here, though, is it's asking for how many t-shirts, rounded to the nearest whole number, would he print in order to maximize his earnings? And what will his earnings be, rounded to the nearest whole dollar, if he prints that number of t-shirts? So when we look at this graph, I can see here, whoops, didn't mean to cross that out, meant to highlight it. I can see there that that is the highest point that the graph reaches. Now we got to figure out, well, what do those values represent? Because one of those represents a dollar amount, another one represents a number of t-shirts. And so here it says that X represents the number of shirts in thousands sold. Now that's really important. This does not mean that, so the X value represents the number of shirts we're going to sell. That does not mean that we're going to only sell 1.15 shirts to maximize profits. That doesn't make any sense. Because to make this simpler, what they did is they, instead of having these huge numbers in our equation, they made these smaller. So then that way now we just have our X values represent our number of t-shirts sold in thousands. So if I multiply 1.151 by 1,000, I actually get 1,151 is how many shirts I'd have to sell to maximize our profits. And then the dollar amount is also in thousands of dollars. Okay, so it says, the reason why we know that is because his total amount earned in thousands of dollars. So that number there that we have, the points, or the 7.242, that's in thousands of dollars as well. So if I multiply that by 1,000, we get $7,242 would be the maximum amount of money he could make if he sold 1,151 shirts. All right, so that's how you do the pink section. So in another video, we'll be looking at the next section, which would be the gold.